solving systems of linear inequalities, we're going to follow the same rules we did for solving a linear inequality when we just had one. We follow the same rules, you have to show the same stuff, okay? So it says here we're going to graph the first linear inequalities boundary line and shade the solution region lightly. So after we've decided where to shade, then our test point, we're going to have that shading be done lightly. We don't want to have it like really dark, okay? Now it says graph the second one, so the other linear inequalities boundary line, and then shade its solution region lightly. And here's what should most of the time be happening. There are going to be some places where you have already shaded and you're going to be shading again. There's going to be some overlap. So the solution for our system becomes that region that is shaded twice, that overlap region. Okay? So we're not learning anything new other than where is the actual solution region. It isn't going to be just anything that's shaded today. It's going to be where do those shaded regions overlap. Okay, so we're going to do number one here where we have our system. We have 2y is less than or equal to negative x plus 6. And we have negative 3x plus 4y is less than negative 8. We're going to take care of the first one and then worry about the second one after we're done with the first one. Okay? So is the first one ready to graph? The boundary lines?
No.
Is it in slope-intercept form?
No.
No. Okay? So our first move better be to get that to happen. Okay? Now here's what we're going to do though. We don't have a whole lot of room on here. So what we're going to do is, I need to just change I need to have a little bit more showing here. Okay, we're gonna actually split this little section here in, oh dear, I need to have a marker. We're gonna split this little section here in like 2 parts. So we can work with one of them on one side and one on the other. So we're gonna take this one, 2y is less than or equal to negative x plus 6. And that's gonna be we're just gonna work with that one. Don't even write the other one down yet. We don't ready. Okay? What do we have to do to get that in slope-intercept form? What would be our move here? Brighton?
Divide 2y by everything but just the 2. Basically.
Okay, every piece of this will be divided by 2. There we go, that's how we'll say it. 2y will get divided by 2. Negative x will get divided by 2. And 6 will get divided by 2. We have to show our work putting it in slope-intercept form. That's not changing. And y is now by itself. Did we divide by a negative?
No.
No, so we don't need to switch the symbols, direction. We leave it the direction it was going. What's negative x divided by 2? Isaac?
Negative 1/2 x.
Negative 1/2 x. Negative 1/2 x. Plus 6 divided by 2 is 3, okay? Is it in slope-intercept form?
Yes.
Okay. So identify our slope and our y-intercept. Doesn't matter which one you do first. You can do both. So what's our slope?
Negative 1/2.
Negative 1/2. Let's write that how it could be. There's 2 different ways we could write that. Give that negative sign to. If we give the negative sign to the upstairs, then the downstairs is positive. Or if we don't give it to the upstairs or give it to the downstairs, we have 1 over negative 2, right? Mm-hmm. What's our b value?
3.
3. Okay. We're ready to graph the boundary line. After we make this decision, should our boundary line be solid or dashed?
Solid.
Solid, because we have the equal to. Okay, go ahead and get that boundary line graphed. Graph the boundary line for this first linear inequality. Graph more than 3 points. We're going to have a lot happening on this graph. We want to have good graphs. So this one, those points are pretty close together. Let's graph more than 3 of them. now we have to decide, should we shade before we do a test point or after? What do you want to do? Do our test point first? Because we have to do a test point either way. I'm going to make you do a test point, so I think you know when you know you got to do a test point anyway, you might as well do it ahead of time. Okay, so let's test what? What do you want to test?
0, 0.
Oh, you guys are good. Why can we test 0, 0 though?
Because it's not on the one.
Because it's not on the boundary line, and we want to test it because it's the easiest. Yeah. Okay, so we're gonna substitute our 0 in to our original, not in slope-intercept form. Go back to its original state in case you did something wrong. 2 times 0 is less than or equal to a negative 0 and then plus 6.
True.
What's 2 times 0 on the left side?
0.
0, okay. Is less than or equal to, what's the opposite of 0 is
0.
0, that negative sign in front of the x. Opposite of 0 is 0. 0 plus 6 is
6.
6. So no, we can't have a negative x, but we can read it as the opposite of x. True or false?
True.
0 is less than 6, so we say that's true. Capital T I'm going to give it. So that means I should shade where the 0, 0 is then, right? Okay, we're going to shade lightly. So we're going to shade and cover the whole part of the graph that you can see. The shading really goes on everywhere, but don't just shade a little part of it. Shade everything underneath that line. Sometimes what students like to do when we're doing these is they like to use colored pencils. And then they shade one of them in one color, the other one in another color, and then they can see the overlap easier. Now, the only problem with that is colored pencil doesn't erase as well as a regular lead pencil does. Okay? But you are welcome to use colored pencils if that works for you, okay? Better for you. Like I used red because I had done the problem in red. Okay, we're ready to do the other one now. So now we're going to go back over here and get our work done for the second linear inequality. We're going to get that one put into slope-intercept form. Shmarky, what's going to be my first move?
Divide.
Divide? Okay. Really?
No, plus 3 on each side.
Add 3x on both sides?
Yeah.
Yeah, I think that's a better move. I like that one better. We can divide, but I like this move better. Okay, so now we have the 4y by itself, and we have negative 8 plus 3x. Okay, Stefan?
Now we're going to divide 4 by everything.
Yeah, we're going to divide, how about, can I change that around? We're going to divide everything by 4. Okay, 4y is going to get divided by 4. The negative 8 is going to get divided by 4. The 3x gets divided by 4. Okay, now we have y by itself. Did we divide by a negative number?
No.
No, so the symbol's going to stay like it was. It's not going to change. Negative 8 divided by 4.
Negative 2.
Negative 2.
Plus
And 3x divided by 4.
3/4x.
Okay. Okay, now you can go ahead and identify your slope, your y-intercept. Is your line going to be solid or dashed?
Dashed.
Is there certain on that, it sounds like. after your boundary line is drawn. We're not done, just because there's already shading in the graph, don't be confused and think you're done. Now you have to do a test point for that one and decide where that one should be shaded as if the other one wasn't on there right now. Okay, so what should we test?
0, 0.
Okay, we can test 0, 0 again, because it's not on our dashed boundary line. So we can test 0, 0. So we'll test 0, 0 for this one also. We always have to make the decision according to the boundary line we're working with. So -3 times 0 plus 4 times 0. And I get the statement 0 is less than -8.
That is false.
Mess. False?
False.
Okay, 0 is not less than -8. So I'm going to shade. So 0, 0 is right here. We pay really close attention here. We are working with this boundary line. You've got to ignore all that other busyness on the graph right now. We're working with this boundary line. We tested 0, 0. It tested false. So where should we shade?
Below the line.
The other side. So we're going to take the other side and we're going to shade over here all of the graph all the coordinate plane we see below that line. Again, don't cover your line, and then you can't tell anymore if it's dashed or solid. And don't shade too dark. And we're shading lightly. And then, after you have shaded the second one lightly, you're going to see if you can identify where there's double shading. So look at your graph really well and see if you can tell where is it double shaded right now. Where is there overlap? You've got to be really careful with this. Some of you did your second shading too dark. And then what you're going to do is you're going to take your pencil bubble, make sure we all agree on it, and we're going to triple shade it, okay? So where do we think that is? So it starts, I'm going to identify it here. It's not up here, it's below this line, so it's kind of like, I'm just going to draw on the graph so we can identify it better. Right here, it doesn't go above that, and it doesn't go above that, so we have this region right here, don't we? Right, all of this, not up here, not over there, but just this kind of like upside down little V area, right? So take your pencil now and make that look like the only solution region really on here. Don't make it so dark though that we can't tell anything else. But what you want to do is you want to triple shade. This is where colored pencils come in nice because you're using blue and you're using green, and then the triple shaded region, or the overlap region I mean, ends up looking yellow, so you can, okay? Yeah, these get messy. Okay? So, when I'm correcting your work and when you're correcting your work, when we're both correcting, we should be able to zero in and say, this is definitely the solution region for the system. Because those other shaded regions got left out. They only work for one of them, but not for both of them. Now, I want us to, though, do a test point from our overlap region, because that should give us a little bit of extra confidence that we have the right solution region. So let's pick a point that's down in this region and test it. Okay, let's test. So anybody want to pick a test point? Can't be 0, 0 this time, it's not in there, sorry. Brighton?
5, -5.
Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. He wants to test this point right here. Okay, why don't you do the same thing I just did? Identify 5, -5. That's what you said, right, Brighton?
Yep.
And put that as a big point kind of in your solution region there. And then we're going to actually run a test with it, okay, and write it out. Okay, so we are testing ordered pair 5, -5. And we gotta test in both of them. Remember, it has to make both true in a system. So our first one was, I can, look at this one. 2y is less than or equal to -x plus 6. And the other one was -3x plus 4y is less than -8. So now we're not testing to decide where to shade. We're testing to see if we have a good solution region. So we're going to substitute in our values from our test point and see what we get. Let's just work with the first one here. I subbed in my -5 for x, or my -5 for y, I mean, and my +5 for x. What's 2 times -5, class? -10. Okay. What's the opposite of 5? -5. And what's -5 plus 6? 1. Okay. We need this to be true. We want this to be true. Is it? Is -10 less than 1?
Yeah.
Okay, so it's true. That's good. We want it to be. Isaac?
I switched the -5 and 5 around, so it's 2 times the 5.
You can't do that because not according to the point that we're testing. You're testing then ordered pair -5, 5. And look at what's gonna happen here, Isaac. -5, 1, 2, 3, 4, 5, +5. Is that in our overlap region here?
No, but if it's 5, -5, then you have to put the 5 first and then the -5.
No, you put it for where this is the y value, this is the x value. So I put -5 in for y and +5 in for the x. You gotta put them in the correct places. Okay, let's substitute into the other one. It's a +5 for x, a -5 for y, -3 times 5, -15, 4 times -5, -20, okay. -15 plus -20. -35 is less than -8. What do you think? Is that true or false?
True.
-35 is less than -8. It's true. So we can feel pretty confident about our solution region. It's one of the solutions to this problem. There are lots of points that are solutions. They come from that overlap region, but we checked one of them. Okay, flip your papers over, let's look at number 2. On the back. Okay. So, what's our process again? Here's our kind of has to think when we're solving these. We have to do it this way. We're going to do them one at a time. So, on your paper, however you divide up your paper, but since I already have this one, we're going to do one on one side, one on the other. Okay, so I'm going to work with this one first over here. 6x plus -3y would be a better way to treat that one. So what should I do first?
Subtract 6x on both sides.
Yep, subtract 6x from both sides. Which is the same as plus a -6x when I write it out over on that right side. What's next?
Divide every piece by -3.
Okay, divide every piece by -3. That cancels my negative 3's in front of the y. I divided by a positive or a negative? Negative, so I have to switch the sign. I have to make sure I switch the sign. 12 divided by negative 3? Negative 4. Negative 6x divided by negative 3? Positive 2x, okay. We're ready to identify our m and b, and solid or dashed. M is 2 over 1 or negative 2 over negative 1. B is negative 4. Solid or dashed?
Solid.
Solid, okay. Okay, let's go ahead and get that line graph then. Make lots of points. You get a good boundary line. Oops, mine is dashed. Okay, and what would be our next move now? Isaac?
You have to do the same thing to the other side. But
Well, not yet.
divide
We're
by,
not done with this one yet. Stefan? We gotta test it. We gotta decide where we're going to. We gotta decide where we're going to have lunch.
No, we're gonna change.
Shade. We're gonna shade it. Okay. What do you want to test? 0, 0. Okay. 0, 0 is what we're going to test. Okay. So back in my original equation, I'm testing 0, 0. 6x minus 3y. 6 times 0 minus 3 times 0 is less than or equal to 12. Well, what happens on the left side? I love when the x's and y's are together on the same side and we're testing 0, 0. What happens on that side? What do we get?
true.
0. We get 0. On the left side we get 0, and on the right side we get 12. True or false?
True.
True. Okay, so that tells us we're going to shade
Above
where 0, 0 is. So we're going to shade above the line lightly, and we're going to shade all the way through the graph above it with our pencil. And then we're ready to move on to the other one after we've lightly shaded that one. Sometimes another thing that kind of works for students is when they're shading one of them, they go in one direction. When they're shading the other one, they go in the other direction. So then they have what's called kind of like cross-hatching. It's kind of like you can see where the lines are crossing, the shading's crossing. Okay, let's go over to our next one now and get it ready to graph. We have, first of all, I'm going to write it as 2x plus, or 2y plus a negative 4x. What am I going to do with this one first?
Add 4x.
Yeah, we're going to add 4x to both sides. And then we will, let's see if somebody can say this right. And then we will, Brighton?
Divide interface.
Divide every piece by 2. Yeah, you almost were getting ready to say it wrong, weren't you? 2y divided by 2, 6 divided by 2, every piece divided by 2. Okay, and then we're going to have y by itself. We need to switch the inequality symbol. Do we divide by a negative? Nope, so we're going to leave it going the direction it is. 6 divided by 2 is 3. 4x divided by 2 is 2x, right? Okay. So, let's see, I better, M is, B is, we got 2 over 1 again, or negative 2 over negative 1. B is 3. Solid or dash line? Solid. Okay, so we're ready to go make our line. Anybody have any sort of a thought enter their head right now when once we got that rearranged in the slope and what'd you say, Malcolm? Oh yeah, how come they should turn out parallel?
Because the slopes is.
Because their slopes are the same, yeah. So we should have parallel lines here. They're not going to intersect, but we don't say, oh, then that means there's no solution, we're done. No, unfortunately, we don't get to have that thought with linear inequalities. We got to look for overlap shading instead. Okay, next thing we gotta do is to somehow get our brains to say, okay, I know there's a lot of stuff going on here, but what's the line I just graphed? And what test point am I gonna use that's not on the line? So here's the line we just graphed, the one that's on the top. What test point, can we use 0, 0 again?
Yes.
Yeah, but it's not on that line, so we can test 0, 0. So we'll test 0, 0, and we'll have 2 times 0 minus 4 times 0 is less than or equal to 6. X's and Y's on the same side, that gives me 0 is less than or equal to 6. True or false?
True.
True. That means I would shade to the left of that line or below it?
Below.
Below it. Okay, so we're going to take our pencil now and lightly shade all of the region underneath it. Whew. Looks to me like when we're done, there shouldn't be any part of our graph that's not shaded. Every part of our graph should have some shading of one or the other. And then there should be an overlap region. So we shade the whole way, and then we decide what is our overlap region. So where is the overlap region?
In between the two.
In between the two parallel lines. It's like a runway, isn't it? It's like an interstate, a straight interstate. Okay, so I'm going to show my overlap region in red. It's between the two boundary lines is where we would triple shade now. So make sure that that runway in between the parallel lines looks like a overlap region. Make it so that you can tell that is your actual solution region. Everything else outside of it should be lightly shaded. Everything really on either side of the solution region should be the same level of shading. One shouldn't be any darker than the other. The only thing that should end up being darker is that overlap region. Okay, we're going to have to skip the test point for testing it to see if we have a good shaded region or not. And in fact, because you didn't get any homework time, I will allow you to skip the last test problem, you know, the one that we did on the front. Remember how we tested the solution region? I'll let you skip that today on your homework, okay? But you have to do the test points for what?
The lines.
The shading for each of the linear inequalities